All right. Now, just a couple of announcements. I think you've heard them before. Well, okay. Goodness, the system's doing strangely. I don't think many of you are probably quite yet graduation, but I think a couple of you might be. If you graduating this term, I hope your application's in already. If not, get it in immediately, okay? If you're graduating next term, though, this is the best time in the world to start your process, okay? Because the process starts with a degree audit. In other words, degree plan. Get your degree plan, look at it, see what you have taken, what you still need to take, and get with your advisor and make sure he or she sees also what you see and that you're both on board with it, and you can already start working on your spring schedule. Now, spring schedule's not out yet, so I know you can't make it, but you can start planning what courses you do need to take in spring in order to graduate in May. Okay. And by the way, time out. For those of you who have been here before, you may not realize this. Those of you who are new here probably know this already. This term, all the other new stuff we're doing, this book, the tutoring labs, all this other new stuff we're doing, here's another new thing that's happening this term, has not happened before. We're having a fall graduation. You've probably seen this already. We used to only have one graduation a year in the spring. It got so big, we had to rent the Civic Center. It was just awkward. It cost the school money. It usually was rugged getting parked. Just lots of things about it. So they've decided to go to 2 graduations a year. They're not going to have one at the end of summer, one at the end of fall, and one at the end of spring. So that's why it's essential to get the fall graduation applications in now, because they have to do the paperwork to get everything done. All right, so you see your advisor, and then once you can go and apply online, but the important thing is once the spring graduation, spring schedule gets out, then sign up for the courses you want. Do it early, because you need to find out if anything you need is not scheduled for the spring. And if it's not, you can check with the instructors, check with the department chair of that department, see if they can get it on the schedule for spring, because we still have flexibility there. Okay? If they can't, then you have time to start on a course substitution. Okay? So, and that takes a little bit of time, so get that going this term so you'll know whether you're going to graduate in the spring or not. Okay? So, and remember that. The term before you graduate, that's the term to apply to graduate. Okay? At least one term ahead. Okay? It gives you plenty of time to make all the plans necessary. All right. Now, I announced this before. Note takers are needed. If you would like to do this, it's a great service to somebody who needs the service, and you get paid for it. So it's a good deal. The person to contact is here. I'll be glad to share that with you. And they need tutors. And you guys would be great developmental math tutors, and maybe even Math 100 tutors. But anyway, they need tutors in math, English, biology, computer science, and Spanish in the Space Center. Now, this is advertised for the Birmingham West Campus. I wouldn't be surprised if they wouldn't want it here, too, but you can apply both places. And they pay you to do it, okay? So please consider that a possibility. Okay, Riley hasn't come in yet. Pablo came in. Okay. Bree with an I came in, right? Okay. There you are. Yeah. Zaria didn't come in, did she? Okay. Bree with an I did. Jig hasn't made it in yet, has she? Saya hasn't. Gibron won't, I don't think. Kyla has not either, but Sierra has. Okay. All right, anyone else whose name I may have missed? All right, any questions on anything we've done so far? Okay, this class has been fantastic about getting your work in very close to right on time. I've received several quizzes today. I received some last time, and that reminded me when I was going through putting things in order that I still had a couple of people that I hadn't returned your first test to. Shayla? Shayla here? Yeah, right. sorry it's not here. Brianna with an I is here. Oh, look at that fair swap. And Kylie. Oh goodness, don't take a one. What are you doing? Okay. The Sassy. Where are you? There you are. Okay. Let's say so. Okay, I'm sorry. I keep saying that. Okay, sorry it's not here. Kylie's not here. And oh, Kylie. Oh, goodness gracious! I thought you said that. Okay, got it. All right. Wait a minute. Oh yeah. Okay. All right. Still one missing, but we'll catch those up later. Okay. That's it. Okay. All right. Ah, another. Give you a thank you. Okay. All right. Any questions on anything? What we've done, where we're going, where we are? Okay. Now, where are we? We're in section, I guess you saw section 11.4B. Okay. We did the focus on factoring that's on the board here, and then the next one is not on the slide, and I've got to get my pen set up, and for some reason, there it comes. Okay. It's being obstinate today. There we go. Okay. Now, this is on Module 11, page 21. Focus on factoring. I won't say that because you need to remember it. Okay. Here we have 8x cubed minus 27. The question is, can we factor that? And what's the answer? Yes, of course we can. We can do it. No. Okay. How would you factor it? I heard something silently in the background. Did someone say something? Okay. Now, let me just say this. Okay. When you have a binomial, two-term polynomial, there's only 4 possibilities. Only 4. What do we always look for first? Common factors. Are there any? 8. No. This has factors only of 2. That has factors only of 3. Okay? No common factors. Okay. A binomial, no common factors, are only down to 3 possibilities. And what are they? Difference of 2. Yeah, difference of 2 perfect squares. Does this qualify? No. Okay. The other 2 possibilities? A little louder. Cubes. What about them? Say again? Oh! Yeah? Say again? Yes, they are perfect cubes. Okay, but can we do a difference of 2 perfect cubes? Yes, we can. Could we do a sum of 2 perfect cubes? Yes, we can. It's the sum of 2 perfect squares you can't do. The sum of 2 perfect cubes you can. Okay? So, how do we do the difference of 2 perfect cubes? You said the first was a perfect cube. What's that a perfect cube of? That's a hanging preposition. Dangling preposition. Okay? What's that? 2x minus 3. Perfect. How do you get the next one? Anyone remember? Square the first, and that gives you 4x squared plus, always a different sign, of what? 6x, you got it. Okay? Yes, and what does that give you? Second? Plus 9. Ding, ding, ding. We have a wiener. Okay, there it is. And you can always check and see if it works. Let's do it. 2x times 4x squared is 8x cubed. 2x times 6x is 2x times 6x. Let me draw the lines there. 12x and 12x squared. And minus 3 times 4x squared is minus 12x squared. Those go to 0. Good. Okay. 3 times, let's say, 2x times 9, 18x, and 3 times, negative 3 times 6x is negative 18x. Those cancel, add to 0. And then finally, negative 27. Ding, ding, ding. We got it. Okay? Any questions on that?
I want to know, when we got the 6x, I just want to know why you put the plus sign.
Say this again?
When you did, when
Yeah.
you got the 6x, I don't get why you.
Why we change signs?
Yeah.
Oh, that's what I told you. Yeah, that's the rule. That's the rule. It's always the opposite sign from here. If this is the plus, that becomes a minus.
Okay.
And that way, those terms will cancel out. The ones that we added to 0,
So we should just
you got to remember that. Yeah, remember, if this is a minus, that has to be a minus. And that then has to be a plus. If that was a plus, that has to be a plus. That one has to be a minus. Always the opposite sign, opposite the product of the two. That's the rule. I made it up. So
the steps for multiplying, you multiply 2x, or the
okay, so
what numbers?
okay, yeah, you do all of them. Okay, 2x times 4x cubed, 4x squared is 8x cubed, right? Then I did them out of order because I was trying to show you, but here I'll do the next one. This will be 2x times 6x is plus 12x squared, and 2x times 9 is plus 18x. Not looking very promising, is it? Until we do the other term. 3x times, negative 3 times 4x squared is minus 12x squared. That's why it had to be opposite. Okay. And then minus 3 times 6x is minus 18x. Yes, yes, yes. And then minus 3 times positive 9 is minus 27. Okay, these add to 0, those add to 0. You're left with 8x cubed minus 27, which is exactly what we had to begin with. That's why the signs have to be the opposite. And you always keep this sign in the first binomial term, change the sign in the middle term, the other. These two signs have to be positive. Why? You squared this and you squared that. Have to be positive. It's the middle term sign. Just has to be the opposite of the middle sign. Make sense? Yeah. Because I said so. Okay. Now, all right. All right. That was that one. Then we have check your understanding 6. Anyone need to see that? Are you okay? Okay. Then we have the practice problems. You have 5 of them. Please do them. Do them all. Okay? Because that's how you get good at it. They don't give you many, so do all those. And all the solutions are at the back of this section on page S10, whatever that is. Okay. So, I really shouldn't have probably even gone to this. Oh, yeah. Okay. I should have just started in 11.4C, but I didn't realize that we were out of slides. So 11.4C. Factor a trinomial that is quadratic in form. My goodness, I thought we were doing that. Okay? If it'll ever come up, we may do it. All right. All right. Here we go. from current slide. Factoring polynomials, we've seen that one before, chapter 11, module 11, section 11.4, special factoring, we've seen that before. And this time we're 11.4C, factor a trinomial that is quadratic in form. They've all been well, not all of them, but most of them have been quadratic in form. So what in the world do they mean by that? Certain trinomials that are not quadratic can be expressed as a quadratic trinomial by making suitable variable substitution. Boy, what a sentence, huh? Okay, what does that mean? A trinomial is quadratic in form if it can be written like this. Yeah, we're used to seeing that. AU squared plus BU plus C. But what if you were something else? Like an x squared, a y cubed, a 7y cubed, or anything such as that. Then it doesn't look like a quadratic, but it still has that form. Okay? So let's see. Here's some examples. Trinomial quadratic in form can be written this way. Now, how about that? Does that look like it could be written like that? Okay, sorry, I'm in the way here. How? I'm an idiot, Chief. How? Okay, never mind. That's not quadratic. That's power of 6. Quadratic means power of 2. So could we write that in a quadratic form? Using an appropriate substitution. The key here is you have a trinomial. That's important, okay? What substitution could you use? Can you see it? That's not too better. Can y'all see it? Okay. What substitution? Here's a hint. They like you. I like you too. Okay. Okay, someone's awake. Okay, good. What's that? Let u equal x cubed. What's u squared then? If u is equal to x cubed, what's u squared? Oh, hard problem. Oh, we finished that last second. No, you may have said it right. Try it. If u is equal to x cubed, what would be u squared? X to the 6th. Perfect. And there we have x to the 6th. So this would be 2u squared minus 7u plus 4. There it is. Let u equal x cubed. Then u squared is x cubed squared, which is x to the 6th. Now you have 2x6 minus 7x cubed plus 4 becomes 2u squared minus 7u plus 4. That's now quadratic in form. See if you can factor that. And if you can, then go back and substitute what u is, or u are, okay? And that would be x cubed. And you got it knocked, okay? Uh-oh. How about that one? Say again? You can't see. You're trying to see the answer. I know what you're trying to do. You're trying to make me stand crazily. Okay, what? In this case, you would be a good student. Right, okay, never mind.
Will you be xy?
xy, perfect. That would be u squared, 5u squared, plus 3u minus 6. And there we have it. And then we can try to factor that. So that's what we mean by having a trinomial, has to be 3 terms, that is quadratic in form, meaning you can make a substitution and make it into another quadratic that you might be able to factor. Now, I didn't check to see if I can factor that. My gut reaction is no, but I don't know if that's true or not. Y'all might correct me on that. And this one, my gut reaction is no. Okay, so they gave you 2 you can't factor, and then you can say not factorable. But they weren't trying to factor it, they're just showing you can write it as a quadratic in form. Okay? Make sense? Sort of, a little bit. Okay. When you use this method to factor a trinomial that is quadratic in form, they like that term, don't they? The variable part of the first term of each binomial, the variable part of the first term of each binomial will be u. Okay. Second? Okay. To me, that's what I would say. I'd say the variable in the second term would be u. Okay, not the first term. But what they mean, the variable u, it'll be raised to second power. But then too, what if your original one had a u cubed in it? Then you have to use a different variable. So I don't see why they say it has to be u. It can be anything you want it to, as long as it's not one of the variables that was in the original problem. In other words, this one you wouldn't say, let x be x cubed. No, that doesn't make sense. It can't be something else. Pick another letter. Their favorite is u, but you don't have to use u. You could use a stick man if you wanted to. It's a little hard to draw, but you could do it, okay? You could use anything you wanted to. Here, what if this was x squared, u squared? You wouldn't choose u. I would choose y or z, or you got lots of other letters you can choose from. But they're saying you always have to use u. No, you don't. But that's their favorite. Just like x is everybody's favorite variable, u is their favorite substitution variable. Even when you get to calculus, you'll find that's the case. They love using u for the substitution, but it doesn't have to be. Okay? How in the world are we going to do that? Huh? Yes, we will. We're not going to wimp out of it. Okay. Say again? Oh, I got to get my pen back. Okay. What's your suggestion? Here's how we'll start. You get to choose your substitution variable. You can choose anything in the world, just not x. Choose one. L? Okay. We'll choose L. Okay. Let L be what? Now, the reason I wrote it that way, if you write it script, it looks just like a 1. And I thought, what a lousy choice. But I didn't say that out loud. I wrote it that way so it doesn't look like a 1. Let L equal what? You had a great idea. What was your idea? I thought you did.
No, I didn't.
Yes, you did. What would that be? Say again? That would be exactly what it would be, square root of x. Then, what do we want next? L squared. And what would be L squared then? X, you got it. Now what does our new thing look like? X is now L squared minus 2. And what's square root of x? What's square root of x? L, okay? Minus 15. One reason I cringe a little bit on using L, another reason, is when I was growing up, I had an older brother, younger brother. You know how younger brothers can be if you ever have had one, okay? And he was wild, okay? And he wanted everybody else to be wild. And when I wasn't wild, he gave me a nickname. And that nickname was L7. Anyone know what L7 is? Huh? A square. He named me L7 because he thought I was a square. And from that point on, even today, I think every now and then he'll say, hey, L. You know, he just shortened it to L. So that's why I don't use L. Never mind. Okay, what can we do with that now? A little bit of history you didn't care to know, okay? What can you do to that? What's the F word? Factor it. Let's see if we can factor it, okay? And what would that be? L times L. Okay, got that down. Then, oh, this was several sections ago. We don't need to know this anymore, do we? Of course we do. Yes, they have to have opposite sign, plus and minus. And now what? 3 and 5. In which order? 3 for the plus and 5 for the minus. Don't know if that works, but we can always flow it and see. L times L is L squared. L times minus 5 is minus 5L plus 3L is? Oh boy, early in the morning. Minus 5L plus 3L is? Negative 2L. Yes, yes, yes. And then? Negative 15. Yes, it works. Are we through? No. No, we have to put it back in. Okay, what was our L? Square root of x plus 3 times. What was L? Square root of x minus 5. Now we're through. Actually, we shouldn't have checked it there. We should have gone on a substitute, then checked it here and see if we got the same thing. You will. Okay? Promise. Okay? But you really should wait till your final answer and then go back and check it. But it's easy writing L, so I like doing that first. Then I almost guarantee that's going to work. Why what? Why what? Okay, why use a different variable? Okay, because if you want to use the same variable x, what if you said let x equal x square root of x? I can only think of 2 numbers in the world that would work for. 0 and 1. It would work for 4, because if 4 was x, that x would be 2. Square root of 4 is 2. So yeah, that won't always work. You need to name a new variable. And U is fine unless you're weird and like L. Never mind, I didn't say that. He wasn't paying attention. Okay. So, all right. Does that answer your question? You just have to use a different variable. Otherwise, you're making up something that probably won't work. Okay. Okay. Even though you could make it look like it was working. All right. I have to turn my pages, otherwise I might miss something the book's doing. Yep, I sure did. We missed the first 2 focuses. Foci. No, the first foci. Focus. Okay. Let's go back and do that. Oh, let's go on and see what they do for this one. And then we'll go back and do the first one. I didn't turn my page. I wasn't paying attention. They wrote it again, and then they said, I sure wouldn't write it here and then put what I did there. I would write it somewhere else. But anyway, let u equal square root of x. Then u squared is x. So this would be u squared minus 2 times square root of x minus 15. Okay, then see if you can factor that. They like u. Okay, I like you too. Okay. Then, sure enough, that will factor as u minus 5 times u plus 3. Y'all did it right. And then you plug back in what u is. Square root of x minus 5 times square root of x plus 3. See that? All right. Whoa, that's the only one they show in the whole subsection. Yeah, whatever. Let's go back and do the first one. Factor this. X to the 4th plus 5x squared plus 6. Is that factorable? What would you do? Say again? Okay. Now, if any of you are wondering this, you may not be, but if you are, do you have to do a substitution? No. If you notice those are all even powers of x's, you can just, in your brain, think, well, let's factor x squared. What's the only possible factor? No, not the only, but in terms of even powers, what's the only possible factorization of x fourth? X squared times x squared. So you don't have to do the u if it doesn't help you. If it does help you, use it, okay? Then where do you look next? Y'all forgotten that already, huh? I'm going to have to rescind your good grades on that quiz and test, okay? Say again? Same signs, plus and plus, okay? And then what? 2, 3, and 2. Perfect. Let's see if that works. What's x squared times x squared? x to the fourth. X squared times 2, 2x squared, plus 3x squared, 5x squared, plus 6. So if you don't like using a u, you want to leave it, and you can think through it that way, you certainly can. There's no harm in doing that. They like doing the substitution, but you don't have to. Say again?
So the first two terms decide your first.
What's that?
The first two terms decide your first term in the when you're grouping.
Okay, my hearing's bad. I'm not following everything.
The first two terms, like x to the fourth and 5x squared,
Right.
that determines your first two terms.
Right. Now, if you're doing a substitution, I thought you said it, that will be your substitution. Okay? Or, okay, it has to be in the form you can do this. Then when you square this, you better get that. So, yeah, if that's what you're talking about, that's it exactly. The variable in the middle term should be what you're substituting for, and that should be the square of that. If that's the case, go for it. And if you like using the u's, use the u's, or any other variable you want, just not x. Or if you can see it, just using x squared. Just treat that, x, and unfold it with x squared. That works as well. Does that make sense? So you paid your money already, take your choice. You do it whichever way you like. Now, I have some students, or have had them in the past, this class is way too good to do this, but they say, oh, don't give me 2 or 3 ways to do it. You just tell me how to do it, and I'll do it that way. No, I want you to do it the way you understand. My method may not make sense to you. You do it the way that you understand best, right? All right. Any questions on this? All right. That was the first focus. It has a check your understanding 7. Please do that as soon as you can after class, okay? Then the one that we did earlier, that one there, it has a check your understanding 8. Please do that one. And then that's all the examples. They go straight to practice problems. They have 5 of them there. Please do them. Please do them. They don't give you many. Please do as many as they give you. All right? Now, if you cannot get all of them right, hardest one in there, get it right. Yeah, if you don't want to do it, it's up to you. All right, any questions? That, folks, is all she wrote for this section, okay? They really waste a lot of thing on their slide set. They duplicate 2 slides, have one other, and then do only 1 practice slide. That's a tremendous waste of effort here, it looks like. All right, let's go. And speaking of wasted effort, I had to copy each one of these individually into Blackboard. They couldn't do them as a group. They had to do individually. That was such a pain. I love this book, but okay, it's so much fun. Okay, actually the book's not bad. I didn't like it at first, but it's not as bad as I thought it was going to be. Okay, chapter 11, or module 11 is still factoring polynomials like it has been for the last 17 of these slides. And then module 11.4, the last several have been special factoring. That's at least 4 of those. And then objective 11.4D is factoring completely. And I think I've told you always have to go back and check. Can you go any further? Don't ever leave it hanging if you can factor any further. All right, so here's the general rules. When factoring a polynomial completely, which we always want to do, ask the following questions about the polynomial. And this is all review right here. First thing we always ask, are there any common factors? If so, factor it out. Factor out the greatest common factor. And once you got it out, look again to see if you missed any, because you might need to do another time. You might not see that 16 will go into it. You only thought 4 would go into it. So do factor out until you're sure you got all the common factors out. Okay? Then, if the polynomial is a binomial, we just went on that. If you've already taken out greatest common factors, if it's a binomial, what's your only 3 options? Oh boy, it's so long ago. Yeah, difference of 2 perfect squares. 2 perfect cubes are sum of 2 perfect cubes. You left out the sum of 2 perfect squares, didn't you? Why? You can't factor them, ever, Okay, you can never factor the sum of two perfect squares. Okay. Now, so that's the only one. If it's a trinomial, boy, you have a lot of possibilities here. It might be a perfect square trinomial. What were the conditions for that? Does anyone remember? Trinomial, 3 terms. Tell me something about those 3 terms. First one's got to be a perfect square. The last one's got to be a perfect square. And the middle one has to be twice the product of the 2. Perfect. Okay. So, check that. Okay. And it says, or the product of 2 binomials. Well, you don't know that. You try to factor and see. Okay. Now, if that trinomial that you have here is not a perfect square trinomial, but the coefficient for the first term has many factors, and the coefficient for the last term has many factors, what might we try? If the coefficient for the first term has many factors, and the coefficient for the third term, the constant in the third term, or coefficient, has many factors, what might we try? AC method, good choice, okay? Now, that's going to lead to factoring by grouping. But if you had a 4-term polynomial, that's your only possible thing to do. We don't know how to do it without factoring by grouping, okay? Now, finally, is each factor non-factorable over the integers? So in other words, if you started factoring and you think you finished, you always go back and look at each factor to see, well, is this one now a difference of 2 perfect squares? Yeah. You check and see if there's any other possibility. If there is, keep factoring. Keep factoring till you can't factor anymore. Okay? And this will do us in good stead when we get to the next thing we're going to do. Probably the next several things we're going to do. But always keep factoring as far as you can. Okay? I call that factor everything in sight. Okay. Now let's see if they start with the first one. No, they don't. Okay. So let's us do the first one first, and then we'll come back and do that one. So I've got to get my pen back. Another joy of the way they do things here. Okay. Factor this. 64y to the 4th minus 125. Why not? Okay. Okay. What might you try? Say it again. The greatest common factor? Sounds like a good idea. What would that be? Anyone know? Make a guess. Say again? Greatest common factor of 64y fourth minus 125y. Okay. Is 64y fourth a perfect cube? 64 is, 125 is, but y fourth is not, and y is not. Say again? Okay. That's a perfect square. Is that a perfect square? No. Okay. Whoever came up with the first idea was right. We just didn't decide what it was. Greatest common factor. Okay, I think I see what she's doing. She's trying to factor this. I look at this and I know 2 will go into it. That'll be 32. 2 will go into that. That'll be 16. 2 will go into that. That would be 8. 2 will go into that. That would be 4. 2 will go into that. And that's 2 times 2. Only factors this has is 2. No 2's in that because it's not an even number. So there's no greatest common factor between the coefficients. But, a y. Why not? Okay. So we factor out the y. Now what do we have? 64. Say again. Y cubed. Minus 125. Now what do we have? You guys over there. What were you wanting? difference of two perfect cubes? Do we have it exactly now? Don't forget the y. It's a factor. And what can we do with the difference of two perfect cubes? Say again? Anything? Oh, maybe nothing, huh? Okay. Now, I should have written it down now. Remember when I was factoring 64? I said 2 times 32. Say again? 4. You got it. 4. Y. Why not? Say again? I can't hear. Oh, yeah. Oh, okay. I see what you're doing. Okay. 4y cubed. Okay. Let me back off a minute here. I was jumping ahead. Okay. 4y cubed minus 5 cubed. Is that what you were doing? Yes. Okay. Now this becomes y. Don't forget your y. Times 4y minus 5. Excellent. Times 16y squared plus 20y plus 25. Ding, ding, ding. Huh? Okay. What she did was say, is that a perfect cube? Yes, it is. That's what it's a perfect cube of. If that's a perfect cube, yes, that's what it's a perfect cube of. Then she takes this number right here, that sign right there, that number right there, and then she does the rest of it. She just put in that step. I was not going to, but if that helps you see it, do it. Do it to it. Okay? All right. No, it's an excellent way to do the problem. That's what I mean. Do it the way you see and it makes sense to you. Otherwise, you're just, fumbling along trying to think like I do, and that's a terrible thing to try to do. Okay? Y'all don't remember the original Star Trek, do you? Okay, with Spock. Okay, once he was doing a mind meld on the nurse, whatever her name was. He said, "Oh, what a chaotic place." Never mind. You don't want to follow my mind. Okay, never mind. Okay, sorry about that. Okay. Okay with that one? All right. That's the example they gave you. Okay? And in the book you'll see y times 4y minus 5 times 16y squared plus 20y plus 25. That wasn't a focus, that was just an example. Okay? Let's go to the first focus. And they don't do that one either. So I'm going to erase all this again. And we'll do the first focus. 6a cubed plus 15a squared minus 36a. I hope everybody left their windows up. Okay. All right. I heard the weather report this morning several times, and I left mine up. Okay. What would be your first step? Second? Greatest common factor. Now we got to find it. What do you think that might be? 3a. That sounds like a good choice. Factor out of 3a, and what do you have left in the first term? 2a squared. In the second term? Plus 5a. In the third term? Minus, say again, 12. Done. Are you through? Okay, now, frankly, folks, I always look and see if I missed any factors. Because I might think 3a was the greatest, but it might have been a 6a. It wasn't, but it could have been. If I only got 3a out, I could still have a 2 in there. Then factor that out too. You don't have to get the greatest common factor every time, the first time. Just take out common factors until you got them all, and then combine them together over here, and then you'll have the greatest common factor. Okay? Next. 3a. Okay, I already got a choice. 2A times A. And you said minus what? Minus 3. And that will leave a plus 4. Boy, you're either quick or you're reading the book. Which are you? Never mind. I won't ask that question. Okay? Does that work? Let's see. 2A times A is 2A squared. I feel good about that. 2A times 4 is 8A minus 3A. Sure enough is 5A minus 12. Now, I'm not usually that quick with it. Okay? I'm kind of slow. Okay? So what I do is break it down. 2A times A plus times minus, and then start trying to find numbers. And if they work, I'm through. If they don't work, then I change numbers or change signs. Okay? And if I expend everything, I might try AC method. And if I still can't get anything, I say it's not factored. This one was factored. Way to go. Any questions on that? Did you want to see how they got that particular factorization? Are you okay with it? Anybody? Okay? All right. Now they have a check yourself, check your understanding 9, and that follows this one, so you can do that if you want. They do have the solution on page S5, wherever that is. Okay? Now finally we get to the one they show here. So let's erase all this. That one. Whoa. X squared y minus plus 2x squared minus y minus 2. Oh, yes. 4-term polynomial, you can't combine any of them. Always look for common factors. Don't see any common factors there. There were 2 common factors in the first, but not in the last. Yeah, no common factors. So the only option is factor by grouping. So let's group the first 2 and the last 2. Now that looks like we factored it. We haven't. We just grouped them. So what do we do with the first group? Common factor there. And what is it? X squared. And what do you have left? Y plus 2. In the second group? A negative 1. And then what you have left is y plus 2. Good insight. Okay? In fact, most of the time, you're going to factor that minus out. And since there was no coefficient, bring out the 1. 1 is the coefficient, you just don't usually write it down. And that does work, right? Now what do you do? X squared minus 1 times y plus 2. Excellent. Are you through? Say again?
Yes.
Did I hear a yes?
Oh, no. Do you got 2?
Oh, no, we don't. Why? That first term is a
2 squared.
it's a difference of 2 perfect squares. I'm not going to be there on the test for you now. Okay. So how do we factor it? Or do we factor it? I can do the last one, y plus 2. Okay, I did that for you. Okay. Can you factor that first one? How? Little louder. X. Good. Okay. Plus 1 times x minus 1. Wow. Good. Excellent. Okay. Fully factored. Can't factor any further. We're finally through. Make sense? Good illustration. Okay. No common factors in this one, but 4-term polynomial, the only thing we can think of is factor by grouping. Now, sometimes to factor by grouping, you have to rearrange your factors. Your terms. This one we didn't. They worked out quite nicely. But if that would have been an x squared minus 2 plus 2x squared minus y, you're going to have to rearrange till you get some common factors in the first group, and then you're usually okay. All right, let's see how they did it. They may have done something slightly differently, unless y'all are reading the book and telling me what to write. Let's see. You wouldn't do that. All 4 terms do not have a common factor. We check that first. polynomial is not a binomial or trinomial, hey, clever, it's a fourth factor. So try factoring by grouping, and they grouped just like we did. Now notice what they did differently, and it's fine. It was legal. They factored out the minus sign here and left the y plus 2. That's perfectly fine to do. Usually I just group what's written there. I don't factor something out. But that's fine. But you have to remember you've done that. Okay? Then, in the first group, what do you notice?
X squared.
Yes, common factor of x squared. Factor that out. That left a y plus 2. And then you had a minus a y plus 2. And what should pop into your head now is, that coefficient there has to be a 1. So that gives us, factor out the y plus 2, and you have x squared minus 1. Just because you don't see a number there, you can always put in a 1. Most of the time, okay? Are we through? No, because that second, we had it first, but that's a difference of two perfect squares. So, factor that, and they got a lot shorter than we did. X plus 1 times x minus 1. Make sense? And guess what? The order of the factors doesn't matter. Okay? If you have the right factors, you got it on. Make sense? Okay. If there are questions, please ask the questions. Don't sit there saying, I don't know what he's doing. Say it. Okay? Ask me. Okay? Now, there is a check your understanding number 10. Please do that as soon as you get out of class, unless someone feels like you need it now. I'll be glad to go over it now. Okay? Then there's some practice problems. They have 6 of them. Please do them. Please do as many of those as it takes for you to feel confident. Yes, I know how to do this stuff, and move on. Okay? And I think that's the last slide in this section. So let's... All right, go to 11.5A. Yes. We're now moving to 11.5, finally. Okay. And I think this is the last big section. In fact, this is the only subsection in 11.5, is 11.5A. If it'll open. So far, it's having trouble. It's just running around in circles and not doing anything. There it comes. You know what this means, folks? How are we doing on time? Ooh. Okay. If we get this one done today, the section done today, we'll be ready for the test on Monday, won't we? No? Want to go for Wednesday? Okay. Well, we'll continue in the next module, 12. Okay, let's set it up for the slideshow from current slide. And factoring polynomials, what a surprise. We're still in module 11. Now we're in section 11.5, and this is solving equations. Why in the world were we doing all this factoring? So we can solve equations. What we've been doing is getting the tools to put in our tool belt, so when we really get a problem, we can use those tools. Without the tools, we wouldn't know what to do. Okay? So objective 11.5A, solve equations by factoring. And this is the only 11.5 we have, I think. All right, and here's what it's all based on. The multiplication property of 0. I've heard it called other things, but this is as good as any, okay? Zero product principle is the one that I hear most of the time. This states that if the product of any entity, I'm sorry. The multiplication property of 0 states that the product of any entity here in 0 is going to be 0, right? If you multiply anything in the world by 0, what do you get? 0. Even 4,585,762 and 2/3. Multiply that by 0 and you get 0. No matter what you have there, 7x cubed times 0 is 0. Anything multiplied by 0 is 0. So if A is a real number, multiply it by 0, it becomes 0. If A is an expression, 4x cubed minus 7x squared, multiply that by 0, you still get 0. Okay? So, what if we have two entities here, A and B, you multiply them together and get 0. What does that tell you? That one of them has to be 0. Either A is 0 or B is 0. So the only way you can get 0 as a product is if one of those two factors is 0. Okay? That gives us a way to solve an equation. If that's a true equation, then either A is equal to 0 or B is equal to 0. Okay? You have no other option. Can you think of any two other entities you can multiply together and give you 0 if one of them is not 0? If you come up with it, submit it, you win the field medal, which is the highest, like the Nobel Prize in math, okay? They don't have a Nobel Prize in math. But yeah, you can't find, if the product of two entities is 0, one of those two entities has to be 0. So this is called the principle of 0 products, or the 0 product principle. If the product of two factors is 0, then at least one of those factors must be 0. So if A times B is 0, either A is 0 or B is 0. And guess what? If you have 17 factors there, and the product is equal to 0, one of those 17 or more have to be 0. At least one of them has to be 0, no matter how many factors you have. It doesn't have to be just 2. An equation that can be written of this form, guess what we call that? This is an equation now. And if you write it as ax squared plus bx plus c is equal to 0, we call that a quadratic equation, maximum exponent of 2, and we call that in standard form. Now, here's a caveat. One caveat. A, B, and C can be any number in the world. Now, most of the time we're going to leave them being integers, okay? But it can be any number in the world except A cannot be 0. Why could A not be 0? A was equal to 0, the first term is what? 0, right? Because if A is 0, 0 times x squared is 0, okay? So that would be 0. Then you wouldn't have a quadratic equation. You'd have a linear equation. And you solve that differently. So the only requirement is A can't be 0. So a quadratic equation is in standard form when the polynomial is equal to 0. That's what we want. That polynomial, trinomial, binomial, quadnomial, whatever many nomials you have there, equals 0. Okay? And the terms are in descending order of the power. 2, 1, 0, last time. Okay? Have to be in descending order. That's in standard form. So a quadratic equation can be solved using the principle of 0 products when the polynomial x squared plus bx plus c is factorable. If that's factorable, you got it not. Because then you take each factor, set each one equal to 0 separately, solve each linear factor then, and you got it done. Okay? So, let's see. I have to check and see if they're skipping anything. Yes, they are. Okay? So before we get started here, let me get my pen set up. Oops. Okay. This is being stubborn today. Yeah, I don't think we're going to make it anyway. So you got your wish, okay. Let's first do this. X minus 2 times x minus 3 is equal to 0. That's not a polynomial. That's a product of two binomials, right? Can you solve that equation? How? Yes, either x minus 2 is equal to 0 or x minus 3 is equal to 0. There's no two entities you can multiply together to give you 0 as a product unless one of them is 0. Gotta be. So, Can you solve either one of those two equations? Please say yes. How? First one, add 2 to both sides, and what does that give you? X equal 2, or add 3 to both sides, and that gives you X equal 3. Okay? Now, is there any way to check this? Yes. Okay, I can't quite hear you say that yet. Oh, that. Okay. Yes, I always slash my zeros. Sorry about that. I was in the Navy, and when you write a log, your log in the Navy, an O and a 0 look alike, so they always slash the zeros and not slash the O's. When you're doing computer programming, a lot of times they do the same thing. If you ever notice, the 0 will have a little dot in the middle of it, and O will not. So I always slash zeros. Also, when I write my Z's, I slash my Z's, horizontal slash, so it won't look like a 2. And when there's one more. What is the other one? There is another one. I can't think of it right now. If I run into it, I'll let you know. Yeah. Okay, so sorry about that. I always slash my zeros. Just an old habit. I've never broken it because it helps me be able to tell it from the 0. I've just got used to it. Okay, now, how do you go about checking this problem? Yeah, plug these values in. When I plug in x equal 2, what does this give us? 2 minus 2 is? 0 times minus 1. When you plug in a 2 there, but 0 times minus 1 is 0. Okay? Plug in a 3, and that gives you a 1 times 0. Okay, good. Is equal to 0. Yeah. So both of those work. Okay? You don't have to check them, but I always like to make sure I've got right answers. Okay. Now, that to me is fine. They say the solutions are 2 and 3. You don't have to do that for me if you don't want to. Okay. So, let's move on to this one. Okay, so let's erase what we got and see what else we got. Wait a minute. Can we do that? Say again? What would be your approach on that one? Oh, you're getting ready to go, aren't you? Yeah. Too early. Okay. What would be your approach? Ooh, I hear gears grinding like crazy. Oh, yes. What? It's what? It is, okay, it's not in standard form. It is a quadratic equation, max and max exponent is 2, but it's not in standard form. Oh, we have to have it in standard form before we can apply the zero product principle. What is that standard form? How do we get it there? Subtract 6 from both sides of that equation. So the left-hand side becomes, you tell me, 2x squared plus x minus 6, and the right-hand side becomes 0. Ding, ding, we're in standard form now. Okay? What do we do now? Any idea? What would be your suggestion? Factor it. Yes, I was just going to have to ask. Okay, never mind. Okay? Because we want that product to be 0. Now, how do you factor that? Okay, there's 2 methods at our disposal. One is called trial and error, and the other is the AC method. Which you want to try? You tell me. AC? Okay. So what's our A? What's our B? What's our C? Negative 6. So what's AC? It's what? Negative 12. Okay, my hearing's not good. What's your B? 1. Okay, I'm going to delay my final thing here for a bit because we're not ready for it now. If we're doing AC method, I'd set up to do trial and error. Okay, now, what we're looking for here are what? Two numbers that multiply to B minus 12 and add to B 1, right? Now, if they multiply to B minus 12, what does that tell you about the two numbers? One's positive and one's negative. Okay? Now, which one's the larger value? Positive or the negative? Positive, because the B is 1. Okay? Now, I can look at minus 12 and tell you two numbers that are opposite signs and only a difference of 1. Can you tell me that? We don't have to go through them all if you can tell me that. The smaller number is negative and the larger number is positive. Second? 3 and 4, because they add to be 1. We've got it right there. What do we do with that? Say again? Yeah, we replace that middle term with minus 3x plus 4x, because that's the same as plus x. So it'll be 2x squared minus 3x plus 4x minus 6. And that's equal to 0. Now what do we do? You just made it worse. It made it bigger and uglier. What do we do? Group! Okay, that's why we did it. We grouped the first two and the last two. What do you notice about the first two? Second? Common factor of x, and that's all. And what's left? 2x minus 3. And in the second group? Plus 2. What's left? Help me. 2x minus 3. Excellent. And that's equal to 0. All right. What can we do with the left-hand side? What do you notice about it? Anything? Left-hand side. What can you do with that? Oh, yes. And what do we do? Pull it out. 2x minus 3. And what do you have left? X plus 2. Now we have a factorization equal to 0. What can we do from there? Say each of them equal to 0. So either 2x minus 3 is equal to 0, or x plus 2 is equal to 0. Let's take the first one first. What do we do with that? We want to solve for x, right? Say again? No, I wouldn't do that yet. Add 3 to both sides. Always move the terms with, get the terms with the x's with the variable on one side and get all the ones without it on the other side. Then you do your multiplication or division. Except you add 3 to both sides, not 2. Okay? I don't know where that came from. So that gives you 2x is equal to 3. And then what? Divide by 2. Okay? And that gives you x equal a beautiful 3/2. Okay? One of my favorite numbers of all time. Okay. Next. Subtract 2 from both sides, and that gives you x equal negative 2. All right. Now, what I would do, and I know we don't have much time, but let's do it real quickly. Let's square 3/2. What does that give us? Square 3/2. Again? Square 3/2. Huh? 9/4. Multiply that by 2 and you get 9/2. Plus 3/2 would be 9/2 and 3/2 is 9/2 and 3/2. 12/2, and what's 12/2? 6. Yes, that works. Now do a minus 2. Minus 2 squared is? Second. Minus 2 squared is? 4 times 2 is? 8. Minus 2 is? 6. Yes, both of those work. Very good, folks. All right. check your understanding there. That's actually a little bit easier problem than what we just did. But we will pick up, well, we'll do this problem. We won't do it again. Remind me not to do it again, but we'll do the, let you see their solution to it. Yeah, thank you. Thank you. Yeah, okay. Are you sure you didn't want to work some more on that one? Because you don't have to turn it in today if you want to keep working on it. Okay. You too. You sure you don't want to work on those two some more? Okay. I hate to see blank answers. Okay. All right.